Nikita Nandvikar. Welcome you in my Pharma online lecture series. We are going to see the physical pharmacy topic, that is the colloids. Can you see this beautiful picture, which is the fog, or you can say mist? So how it is part of colloid? So let's understand. So whenever you mix two things together, one form is getting mixed into another form. Okay. So based on that, you have two phases. One is disperse phase and another is a dispersion phase. Okay. So disperse phase and another is a dispersion media. Suppose there's an example of making a salt solution. You take spoonful of salt and you add into a cup of water or glass of water, you mix it, you dissolve it. So your salt becomes an internal phase which is less in quantity and which is not continuous. But water which you have taken to make the solution, it is more in concentration, more in quantity, it is continuous and it is called as the external phase. So in case of this salt water, your salt become disperse phase, which is discontinuous and internal phase and less in proportion. Whereas your water becomes the dispersion media, which is continuous, external phase and the large in proportion. So if you see this diagram in which these small particles are dispersed, so this is a solution where the small particles are dispersed throughout. So these particles, it is called as the disperse phase, and the solution is called as the dispersion media. Disperse phase, it is less in proportion, internal phase, and it is discontinuous. Whereas dispersion phase, it is more in proportion, continuous, and called as the external phase. Now, how your system appears, based upon that, it is classified as a molecular dispersion, colloidal dispersion, and the coarse dispersion. So I tell you three simple experiments which you can do at home. First experiment, you can take the salt and water. In second experiment, you can take rice slurry in water. And in the third experiment, you can take sand particle in water. So take the transparent glass so you can observe very well. So mix the salt in water and see how it appears. In second experiment, you take the rice flour and mix it in the cold water and make a slurry, and then boiled water, and in that boiled water, hot boiled water, you add this slurry slowly with stirring and see how the water is changing. And in third one, you take a sand which is fine, and you mix in water and stir it and you see how is the appearance. So in the first case, salt and water, you will see after some time, once the salt is completely dissolved, you will just see the plain water. The system is homogeneous throughout. So this system, which is homogeneous, it is called as the molecular dispersion and also called as the true solution. Your salt water, then sugar and water, even your air is also an example of this homogeneous system where it's a molecular dispersion and the true solution. Second you have is the colloidal dispersion, which is heterogeneous. Now this second experiment which I told you, whatever was the clear water, you will observe that the water becomes turbid, or you see the hazy water you can see. Whatever rice flour you added give the gel appearance and the water becomes turbid. The system appears homogeneous. So this is the phase where you can see the changes, and this is also the heterogeneous system which is called as the colloid. And third system, which is the coarse dispersion, I have told you, the when you mix soil or sand into water, you will see first it is distributed inside the glass. After some time, some particles will be scattered inside the water at the top, and some particle, because they are heavy, they will start settling down, and it is a type of heterogeneous dispersion. So for this first time, the particle size is very small, because of which it appears uniform throughout the system. The particle size is less than 1 nanometer. Okay. But in case of the second colloidal system, the particle size is bigger than the solution. It is more than 1 nanometer but less than zero point 0.5 micrometer. So because of this particle size, your system is not very much clear or transparent. You can see turbidity, haziness, but it is uniform inside the glass or container, you can say. And the third is the suspension, where the particle size is greater than zero point 0.5 micrometer, and you can clearly see with your eyes the system is not homogeneous, it is heterogeneous. So molecular dispersion, you have an example: salt solution, glucose solution, sucrose solution. Colloidal solution, your daily milk which you drink, is also an example of the colloidal solution. Then coarse dispersion, the suspension which I told you, and the various powders which are above this coarse particle size, it is also an example of the coarse dispersion. So for molecular dispersion, you have particle size less than 1 nanometer, and these particles are not even visible under the electron microscope. But if you take colloid, they are invisible under electron microscope and ultra microscope, but they are not visible in your normal optical microscope or your lab microscope. And in case of this coarse dispersion, these particles which are there, you can see even under the optical microscope, which is your lab microscope. Now next is their crossing tendency. Now this solution, that because they are very small, they pass through the semi-permeable membrane and even the ultra filters. Okay, so because they are very small in size, they crosses the semi-permeable membrane and even they crosses the ultra filter. In case of this colloid, they get filtered through this ultrafilter, passing through your regular filter paper. And this coarse dispersion, because the particle size is greater, they do not cross the semi-permeable membrane, and even they do not cross the ultrafilter as well as your regular filter paper. The experiment which I told you, you can filter solution through filter paper and see what you get down. You will get the clear filtrate. Now this colloidal dispersion, that is your rice slurry mixture, you try to filter through the filter paper. Down filtrate which you are getting, it is also colloidal. There is no difference. But if you filter the suspension of the sand particle, you will get the clear filtrate, clear liquid, and all the particles will get accumulated over the surface of the filter paper. Now next you have the diffusion. The solution particles are very small, they cross the permeable membrane and they undergo the rapid diffusion. If you see the colloidal particle and the coarse particle, because the size is greater, they may undergo diffusion, but the rate of diffusion is less as compared to your solution. Okay, and then the settling. Now, clear solution, because they are solution, there is no settling. If you see the colloidal solution, the same experiment which I told you, you see the glass appearance of the system will be same. So there is no settling because the colloidal particle size is less, and there is counterbalance of the interaction between the particle, the attraction repulsion interaction which is there inside in between the particle, that is balanced. So there is no sedimentation or no settling. But if you see the suspension of this sand, you will find that yes, there is a sedimentation because the particles also heavy and there is not uniform distribution. The heavy particles settle down. So example for your molecular dispersion is, I told you, glucose solution, then salt solution, then sucrose solution. Your air is also example of this molecular dispersion. Colloidal dispersion, you have milk, gelatin solution, then your HPMC solution, carbopol solution. These are our example of the colloidal solution. And suspension, I have told you many suspensions which you prepare in your lab, that is also example. Then sand water distribution. Then various coarse powders which are greater than core size is example of the coarse dispersion. Next, you have the shapes of the particle size. Spherical shape, you have the rod shape like elongated structures, and you have long rod, which are the long elongated structures. You have the prolate ellipsoids and you have the oblate ellipsoids. You have the flakes. You must have seen the sodium hydroxide in your lab. There are flakes of sodium hydroxide. And various waxes comes which are also flaky in nature. Then you have the long thread-like structures, which are the very thin thread. When these threads are coiled, you can say it is loosely coiled when the threads are like coiled. And the branch, like you have branch to main part. So for the diffusion, if the particle shape is bigger size, the diffusion will be less. So you can say the thread or this long rod will have more diffusion as compared to your this spherical shape or this oblate ellipsoid shapes. So if the particle are small size and different small shape, they will cross the membrane faster and it will enhance the rate of diffusion. So this is one of the factor, the shape matters because it affects the diffusion and hence the therapeutic action of the drug. Kindly like, share, subscribe my channel and keep watching my channel till end.